Today's speech is about the habitable zone and its peculiarities. What makes a planet habitable, and are there other planets that harbor life the way Earth does? The aforementioned questions will get an answer in the following speech, and hopefully it will make us eager to know more and try to discover new things about our planet and the others in the solar system. The universe is commonly defined as the totality of existence, including planets, stars, and galaxies. It contains about 100 billion galaxies. Galaxies are sprawling space systems composed of dust, gas, and countless stars. Each of them contains about 100 billion stars, and some of them are similar to our own Milky Way galaxy, whereas some others are quite different. Many of those stars have planets orbiting them. Is it possible to look for life in all that immensity? It's like searching for a needle in trillions of haystacks. Let us simplify a bit the topic by thinking more practically. Being as practical as we can help us understand whether other habitable worlds exist. First of all, let me provide you with an overview of what do such planets looks like. The answer is found right here, on this planet where we have already spent a part of our life, because this is the only planet in the universe that we know for certain is habitable. When we look at Earth from space, we see a blue, watery world. It's no coincidence that three-quarters of the surface is covered by oceans. In other words, water is the principal element that makes life possible on Earth. Because of its unique chemical and physical properties, water is absolutely essential for all life as we know it. Fortunately, water is very common in the universe, but life needs water in form of liquid, not ice and not vapor. Can water exist in every planet, in all environments and under any climate conditions? The answer to this question leads to the second point of my discussion. The main important factors for a planet to have liquid water at its surface are the following. The planet has to be large. Uh, the planet has to be large enough so that the force of gravity keeps the water molecules from flying off into space. For example, Mars is smaller than Earth and so has less gravity. The planet is to have an atmosphere because without an atmosphere the planet is in vacuum and liquid water is not stable in a vacuum. For example, our moon has no atmosphere, and so if you spill some water on the moon, it will either boil away, vapor, or freeze solid to make ice. Without the pressure of an atmosphere, liquid water can't survive. The planet needs to be in the right distance from its star. Too close and the surface temperature will exceed the boiling point of water. Too far and the surface temperature will fall below the freezing point of water. Thus, oceans would either vapor or turn to ice. Our third point of discussion is the so-called perfect zone, where the water stays liquid and looks like a belt around the stars. We call that belt the habitable zone. So when we search for habitable worlds, we definitely want to look for planets that are within the zone and resemble to planet Earth. This is not a simple process, but rather a complicated one. This is due to the fact that the planet is not suddenly habitable just because it is in habitable zone. As stated previously, one important factor uh, that shows the existence of water and, as a result, the existence of life is atmosphere. Therefore, for an alien astronomer, Venus would be the habitable because it has the right size and it has an atmosphere. But Venus is not habitable, at least not at its surface, because it's too hot. That's mainly due to the Venus atmosphere, which is full of carbon dioxide. In fact, its atmosphere is entirely carbon dioxide and is almost 100 times thicker than ours. Therefore, the temperature is hotter and the planet So the temperature is hotter and the planet is hotter and the planet is dry as a bone. So finding planets of the right size and distance from the stars is only the beginning. We also want to know about the makeup of their atmospheres. Another complication emerges that when we look a little more deeply planet Earth. In the last 30 years, we discovered a plethora of microbes living in all sorts of extreme environments. We find them in fissures of rocks miles beneath our feet, in boiling waters of the ocean floor, in the waters of thermal springs, and in cloud droplets miles above our heads. These so-called extramolecules are rare. Some scientists estimate that the mass of the microbes living deep underground equals the mass of all the life at Earth's surface. These microbes don't need oceans or sunshine. These discoveries suggest that Earth, like planets, may be only tip of the astrobiological iceberg. It is possible that life might persist in Mars. Microbes that may thrive in Jupiter, where liquid water oceans probably lie beneath the ice crust. To conclude, we know life as an activity that happens under certain circumstances, climate conditions, and in the presence of water as a liquid form. Have we ever thought about life using a liquid other than water? Maybe we are the crazy creatures living in an unusual and extreme environment. Maybe the real habitable zone is so large that there are billions of needles in those trillions of haystacks. Maybe in the big scheme of things, Earth is one of the many different kinds of habitable worlds. The only way to find out is to go out and explore.